All right, it was obviously a little bit of a slower start this morning trying to get all the technology to work. I know you guys are hopefully up and ready to go for the next week. I appreciate everyone who logged in and sent me your written work. Make sure if you have any written work, that you do have it turned in preferably by the end of the day. Um, our grading period ends on Friday. So I was trying to get everything in by today. Please check Google Classroom for all of the information that's needed, and we'll go from there. So, welcome back after spring break. I hope you had a restful, safe um, couple days. I know we got a lot of work done here. Um, so I wanted to finish up the chapter. I had said that that was something we were going to get started with today. I want us to be able to look at what's called direct variation and inverse variation today. We've done direct variation before. It's kind of this um, linear equation situation where we don't have an actual y-intercept other than our origin. So our direct variation has this constant ratio, and that's going to be the difference between direct variation and inverse variation. Is direct variation is going to have a constant ratio, our slope, so to speak, where inverse variation has an actual constant, a whole number type answer that gets to be the same no matter which way you work it out. So direct variation and inverse variation are obviously opposites of each other. So we're going to do both of those today. You can read through all of this on your own, but typically what we're looking for is this phrase everywhere we go. So we're looking to see if it says y varies directly as x. And of course, we're not going to be that obvious every time. Please keep in mind as we do this, it could say the number of dogs varies directly as the number of kennels available. As I look over at my two dogs crated, that's where that came from. But it's the idea that you're going to have something that we're going to talk about varies directly, the words, as, and then some other topic. So when we're all done with this, you'll see that the last example in both are essentially word problems. And we're going to label so that it looks exactly like our formula. And that's going to be something else that I'm going to suggest is that you always set up with a formula. Makes it a lot easier. So we have for direct variation, this is what we were accustomed to looking at, and you can see that we do have two direct variations. Now, I went to Khan Academy to look to see if their version was simpler than the one I made up. And our book has a way of explaining it in a couple different ways, and I will say that the proportion still seems to be the easiest. So I've looked at this in a couple different areas before I decided to go about this year via live stream. And I will tell you that looking at two direct variation problems and labeling it the way we're going to will work much faster and easier using this proportion setup. So this formula right here is what we want to concentrate on. The minute we see direct variation, we want to immediately look at that proportion. So when we see varies directly, we want to concentrate on that proportion. So I've all ready to save us some time. And again, you guys can follow along. I've set up our problem already here. So the example problem says if y varies directly as x. So again, we have this setup. Now, just like our formula setup here, if y varies directly with x, if y varies directly with x, then this is going to be our proportion. So what I want to make sure is that every time I do this, if I want it to fit this formula, I want to see whatever is first as my y. The varies directly tells me what proportion to set up. Whatever is second is always x. Now, I know that seems kind of silly right now because you see a y and you see an x, so you're like, well, of course. This could be z. This could be y. And I would still put a y above this and an x above this so that I know that I am still talking about the same thing. So make sure whatever is first, we name y. Whatever is second, we name x. So if y varies directly as x, and y is 15, so that's the first y that's mentioned, when x, that's the first x that's mentioned, is -5, find y, there's our y2, it's the second one mentioned, when x, the second one mentioned, is 7. So there are pretty much just 3 steps to this. Determine which type of variation so that you know what the formula is. So the first thing we did was we figured this was direct variation, and I wrote the proportion down so I know where to put the y1, the x1, the y2, and the x2. Second step is label the variables in order. Your y1, your x1, your y2, and your x2. Now, I am going to point out that we have this if. That's kind of our hypothesis. And in our hypothesis, it tells us what the variation is. So that's where our formula comes from. As x, so it's telling us which of the variables. And, so this is still part of the hypothesis. That's where this and kind of helps me know that it's still connected to the hypothesis. So the first part. That's how I know these are the x1s, y1s. Okay, try not to get that clogged up in your brain like we're talking about slope or the point slope formula. When we see the word find, that's immediately going to tell me that I'm dealing with those y2s and x2s. So that's why I also know that that should be where the y2 and the x2 come from. At that point, the hardest part is done. Knowing what to label and knowing what proportion to plug it in. And even with the word problems, you're going to find that's going to be the hardest part. Plugging it in and solving it's going to be the easy part. So we plugged in all of our y1, x1, y2, x2, cross multiply and solve. And at least for this practice situation where there's no real word problem, label it, how many crates were necessary for how many dogs and that kind of thing. We just found that if this would fit, y would be -21. So what we actually found is if I plugged that back in here, this -3 situation would match this -3 situation. The ratios remain the same. So we need to make sure that that's what we're looking for. So again, our first step was to determine what type of variation. Our second step is to determine what our labels are. And so we do that with every problem. And our third step is to fill in the proportion and solve. And I will say typically, even when you get to the word problems, which again, you'll see quite a few of them do show up with just our standardized testing, you still see this phrase varies directly or varies inversely. So it's not like they change a whole bunch. All right, so again, I'm going to load this to our notes in Google Classroom. So if for some reason we're missing something or a label as you're watching or as you're taking notes as we go, you can absolutely pause and pick up where we left off. But again, make sure that you recognize what the variation is. Did we label, plug into the formula, and solve? If you are with me right now, go ahead and just type in hi so that I can go ahead and get some attendance, please, just to see who was with me at the 9:30 time. All right. Hi, guys. I appreciate it. Okay. So, awesome. So here's the next example. Again, this is one that I wanted to point out so that you can see we don't have X's or Y's. So again, it gives us a different description for our Y1 and our X1. So above each of these, you can see whatever this first thing was before the varies directly, I've labeled Y. Whatever came after varies directly, I labeled X. So now that allows me to pay attention to, in this first part, the if, the and, so again, kind of like our hypothesis, whatever is still a part of that, I'm going to label all the R's the Y's. So this first R is now Y1. The first T is our X1. After the word find, so where the question is, that's where the Y2 and the X2 show up. But again, it varied directly. I set up my proportion. I label everything with the Y's and the X's, and then I plug in. So our Y1 was -20, our X1 was 4, our Y2 was R, and our X2 was -6. And again, when we cross multiply and solve, we end up with 30. So if I plugged that back in, you'll see that the ratios remain constant. They're equal. And again, that's the whole idea of a proportion, that they're supposed to remain equal. Now, like I said, these first two examples are pretty vanilla. They're pretty straightforward. They're going to just allow us to practice the steps, to label and to go through. And then after we look at, well, then what does this actually mean when we look at it in a word problem situation? So I'm going to give you a second, and I looked at something that, at least for us, for those of us that do or can drive, we're talking about what would happen if we're looking at, if a gallon of gas costs $1.29, how many gallons can you get for $20? So it's this idea that in this word problem, you can see that it says that the total cost of filling up your car with gas varies directly with the number of gallons of gasoline you are purchasing. If a gallon of gas costs $1.29, how many gallons can you get with $20? So this example looks very different from the first two that we did. It is still set up the same way, though. We still have to go through the 3 steps. We still have to look to see what type of variation it is. We still want to label our X's and Y's, and then we want to fill in the formula and cross multiply. And I said from the beginning that the hardest part's going to be identifying your X's and Y's. So the first thing I'm going to do is identify what type of variation this is. And it does say direct variation. So first thing I'm going to do with direct variation, I'm going to write down my y1 and my x1, y2, and x2. All right, so first step's done. The second step is we need to label our y's and our x's. So before our phrase varies directly, we have total cost of filling up your car with gas. So this total cost of filling up, so this cost is the y, and the number of gallons is going to be your x. So when we're looking at how we did it with all of these guys up here, we're going to be doing the same thing, just labeling our words with our variables. It does say a gallon of gas costs that much. How many gallons can you get with this? So here's the trick. It doesn't look like we have enough numbers. I'm hoping that you guys were faster than I was. A gallon is actually the number 1. And it does say cost is $1.29. Now, the other thing I want to point out is this is still part of that hypothesis situation. There's that word if. So because we're still in this hypothesis situation, these are our y and x ones. Now it says the total cost is the y. So that's this guy over here. Here's our y1. Number of gallons is supposed to be our x. So here's our x1. Now, after the word how, that's kind of like our find. This is now actually the question that's being asked. So this is our find word. So that how many. And it says, how many gallons can you get with $20? So gallons and $20, we now have our x2 and our y2. So we do have to pay attention to the labels. We just have to make sure that what we started with on top, total cost was y, number of gallons was x. So everywhere I see a cost, that has to be my y's. Everywhere I see the gallons, that has to be my x's. The hard part is now done. We've labeled everything. We know what formula to use. And now it's just a matter of plugging everything in. So our y1 was 129. Our x1 was 1. And that's because that's a gallon. Our y2 was $20. And our x2, we don't know what that is. That's how many gallons. So you could even name that G or gallons. And then we cross multiply and solve. So 129G will equal 20. And we're going to take 20 divided by 129. And we end up that the number of gallons is about 15.5038. So we can say that for $20, we can get about 15.5 gallons. of gas, which is pretty darn good considering. And I did use the $1.29 was up the street apparently the other day, I was told. I was also told Sam's Club had it for $1.13, but I don't drive anywhere lately, so here is how we would write our answer. If it was multiple choice, they would take care of that for you, but that is our direct variation. So again, label, plug it into the proportion, solve. Now, for the most part, I know that there are some of us that I can honestly say would guess and either do division or multiplication, and at some point would stumble upon the problem. And I know for a fact that direct variation we have done before, where we have found K and then we have set up the problem again to solve. It is truly what we're doing here with our proportion. We're just saving the double step. So back in the first semester, we did direct variation with that y equals kx. And then we found K and we set the problem back up and we plugged everything back in. But we had two different steps in order to do that. I'm sticking with the proportion right now for direct variation because it will help with all of the other variation problems, as well as just give you another way to think about direct variation. It is going to be the one that truly gets used the most throughout your math career. So having two different ways to look at this will help. So if you look back in your notebooks from first semester, you'll find direct variation. You'll find no matter which way you do it, you'll get the same answer. Now, the reason I do it with the proportion is it does help limit the amount of work, especially when we get into our other variations. So that is direct variation. I'm going to cross over now to inverse variation. You'll notice the steps are going to be a lot of the same. And with inverse variation, we still have our relationship with variables. It can be expressed in our function notation, except the two variables always multiply together to give us the same constant. So our setup is a little different than direct variation. Direct variation had y equals kx, y equals kx. Now we have, no matter what we're working with, that when it's multiplied together, you end up with the same constant. So from honors geometry, what some of you would remember is we called this like the means extremes product theorem or the means extremes ratio theorem. Again, a lot of information that honestly, if you don't remember, don't worry, because as long as you follow the formula, you will be okay. So this right here is now the formula. Notice our x1 is now over y2. We flip-flop some things, and we have x2 now on top over x1, or excuse me, y1. So you have your x's on top, and you have your y's on the bottom, and we flip-flopped 1 and 2, 2 and 1. So there's a lot of opposites happening here, which kind of makes sense if we're talking about the inverse. So with our inverse variation, our steps are going to be identical. What we're looking for is still going to be, notice it's all set up the same way for the practice problems. If something varies inversely as something else, and so the setup is all the same. We're doing nothing different but identifying the type of variation. That's why that was supposed to be such an important step. So in this first step, we do have varies inversely. And the first thing I did was write down this proportion. Now here's where things, for some of us, you can get caught up with variables and not pay attention to the order. Because of the way our formula is written, because we write it according to y varies inversely as x. That's our formula. I don't have y first here. They decided to put x. I have to remember that my formula is built y varies inversely as x. So that means everywhere in my problem now, I have to label it appropriately. So here's our if, here's our and, here's our find. So we know whatever comes in the hypothesis, the first part is always the ones, and what comes after the find is always our twos. So before varies inversely is always the y. So I don't really care what variable this is. I'm hiding it on purpose. It's always the y. Varies inversely as whatever comes after it is always x. So now what I have to do is, okay, y1 has to be whatever this is. So because it says x equals 24, that is now my y1. Our x1 is now this guy, where y equals 4. Now, it made it easier when it was f and g earlier. But that's why we're double checking before we go any further. After the word find, I see that now I have to have my y2 is this unknown, and my x2 is now 12. And then I double check before I start plugging everything in. So now what I'm going to do is I have my formula. The hard part is done. We've determined the type of variation. We've labeled everything. And now we're going to fill in and solve. So our x1 is 4. Our y2 is x. Our x2 is 12. And our y1 is 24. So again, I'm not even looking at what the variables are in black anymore. I'm only paying attention to what I did in red. I've had students in the past rewrite the whole thing, and instead of using the variables, they would use the correct ones from the formula. I've had students in the past use markers over word problems and go straight over everything, whatever's easiest for you. So we plug everything in, we cross multiply, and we end up with x is 8. So again, this could be something where, again, the amount of rain that falls varies inversely with the ratio of the clouds in the sky or something. But it's, again, the idea that what we're looking at is this varies inversely statement. All right, so let's walk away from these x's and y's, and let's look at this one. We're back to f's and g's. First step, we have if f varies inversely as g. So again, some phrase varies inversely as some phrase. Find, so we've changed some things. F when g is -6 if f is 15 and g is 9. So here we flip-flop some things, and I purposely put this in here to give you a different look. Here's our conclusion. Here's where it says what we want to know. So notice how when I started this up here, as we determined what it said varies inversely, f was now my y. The second one was my x. So that means if I'm with this find, my y2 is what I have to label here. And my x2 is what I have to label here, because this is part of the what am I looking for. Here is still part of the initial explanation, our hypothesis. So here's our y1, and here's our x1. And again, I'm even now disregarding what was written in the problem. I'm looking at directly up here, the y and the x that I've labeled. So I've determined what kind of variation. I've labeled everything appropriately, proofread it to make sure, and then I have my formula, plugged everything in, and cross-multiplied to solve. The labeling is, again, probably the hardest part. Okay, so just like our direct variation, we've had the practice problems for us to kind of see how this is set up. So now what we're going to do is we're going to take a look at our word problem. Now I took this one right out of the book, and I did so on purpose because it is different. And I didn't want us, if we're going into the book and wondering, how did this happen? I didn't want you wondering, why is it not the same as some of the other ones? So I hate that. I can honestly say I feel like you guys, you give a problem in practice, in the notes, you give homework problems, you give practice problems, all of a sudden you get to a question, you're like, well, they never taught us that part. How can we now do that? So I wanted to make sure that we looked at that one specifically, and it says, and I love this because I was reading it out loud, and are you teaching math or science? The apparent length of an object is inversely proportional to one's distance from the object. Now, the apparent length, meaning what it looks like. So, of course, if you're sitting someplace, and I know you've all done this, where you're sitting away from somebody and you close one eye and you use your two fingers to kind of pinch the size of the person's head you're looking at, or you're approximating how high a tree is, and you use your thumb and your forefinger to measure how big it is. That's kind of what this is talking about. The apparent length of an object is inversely proportional to one's distance from the object. So how far you are. So if we were sitting in the classroom and I looked out at Rachel sitting in the back of the room, I could put my thumb and my forefinger and pinch her head. That would be the apparent length of her head, inversely proportional to the distance that I'm standing from her. And it says Earth is about 93 million miles from the sun. Jupiter is 483.6 million miles from the sun. So we're talking from the sun, from the sun. Here's where things changed. It says, find how many times as large the diameter of the sun would appear, so apparent length, on Earth as on Jupiter. So again, Earth is closer to the sun than Jupiter. So of course, the diameter of the sun is going to be a much longer diameter than if I was on Jupiter. It would be a lot shorter. It would appear to look a lot shorter. So the first thing I did was we wanted to determine what kind of variation this was. And we see inversely proportional. So it is telling us that we are using an inverse variation. So that means whatever comes before is our y, so the apparent length of an object, to one's distance from the object. Now you'll notice that we have this idea of the apparent length of the object. So I did it this way, and we'll look to see if it works in a different way. But I said, okay, we're on Earth. Earth is y1, and it's about that many miles away from the sun. Our distance x is x1 from the sun. Jupiter, we've got our Jupiter, y2, is about that many million miles from the sun. Find how many times as large the diameter of the sun would appear on Earth as on Jupiter. So here's where it's different. We don't have something that we're actually looking for the length of or the distance of. We're looking for how much bigger is it going to look from one to the other? So I chose Earth as my y1 and Jupiter as my y2 to kind of keep this how many times situation. So I'm actually looking for something to be Earth in terms of Jupiter, knowing how much more is it going to be Earth as on Jupiter. So we did the first part, the inverse variation. So we determined what that was, and I'm going to label this the x1, y2, x2, y1. Remember, x is on top, y is on the bottom. We flip-flop 1 and 2, 2 and 1. Then what I'm going to do is I'm going to plug in our x1, we said was that 93 million miles. Our y2 was this Jupiter that I don't know what the sun's diameter is going to look like from Jupiter, so I have that still as my variable. My x2 is the actual distance from the object if I'm on Jupiter, so 483.6. But again, my y1 is, I don't know from Earth what the diameter of the sun is. So I'm going to keep this still as E. So again, from Earth, the diameter of the sun has a certain look. From Jupiter, the diameter of the sun has a certain appearance. Then what I'm going to do is I'm going to cross multiply. So 93 times E equals 483.6 times J. Now we just have to figure out which way do we divide. Well, it says find how many times as large the diameter of the sun would appear on Earth as on Jupiter. So we want Earth in terms of Jupiter. So we're going to divide both sides by 93. And we end up with 5.2 J. So what this says is if we're on Earth, the diameter of the sun is 5.2 times as big as it would be on Jupiter. So again, it's this idea that the same setup, the same steps, set up your proportion, plug in. But the idea was, in this case, we had two variables. It was this final sentence that told us how to leave this. And I know there's been times where you'll read a question, solve for x in terms of y, or solve for y in terms of x. And we have that where we're like, well, I can't solve because I don't have enough numbers. You're not looking for an actual one answer. You're looking for a description, and that's what we were looking for here. We were looking for a description. Earth in terms of Jupiter. Earth in terms of Jupiter. So that's one of them that I specifically wanted to look at. Most follow the same steps that you've already seen with direct variation and with inverse variation. That one was a little different, but because it was in the book, I wanted to explain why it turned out that way. Now, what you will find is I will post these notes to Google Classroom. This week, you will only have one assignment. You will find that posted shortly. As usual, you will most likely see these notes as well as past notes that I have used. And I will post all of those so that you can reference not only today's live stream, but last year's information. They're all different. I made sure of that. Wednesday, we will talk about the other two variations, and we will be done with this chapter then at that point. I will, if there's any written work for this, I'm trying to we're not going to do a no reassignment for this. This will have a separate assignment. I'm going to try to load that here within the next 12 hours. I haven't decided if I'm going to put it on Google Classroom specifically or if I'm going to give you the written work, and then you'll do the same thing where you'll take a picture of it and scan it in. I think I'm going to try Google Classroom and see how it works. So you will see all of this loaded to Classroom. Make sure you do check Google Classroom before the end of the day just to make sure you have all the information. And then I will talk to you again on Wednesday. I hope everyone had a great spring break. Is there any questions you want to ask me before we sign off? All right, I will then talk to everyone Wednesday. Have a great day. Yes, Laura, I did. Yes, we should see all of those in the grade book, like I said, by the end of the week.